Another situation that comes up frequently, particularly in algebra problems, is a case like these where you do your calculations and your answer ends up being multiple intervals. And for your final answer, you need to take either the union of those intervals or the intersection of those intervals. So what we're going to talk about here is how to take something like my two examples here and combine them, hopefully, can't always do this, but hopefully combine them into a single interval. So in both cases, the union and intersection, there are really two sub cases that we need to be concerned about. One is the case where the two intervals overlap, and the other is the case where they don't overlap. All right, so let's take a look at this first example here. When you, at least when you're starting out with these, I think it really helps to just sketch a quick number line and get a visualization of what this interval is trying to say to us. So I've got a number line here, and I'm going to start by graphing the interval from 1 to 4, and I put a solid circle to indicate that we want to include 1, and I put nothing on the right-hand side to indicate that we don't want to include 4. Okay, so now we'll do the other one, right? The interval from 2 to 5, and we use the same open circle, or excuse me, filled in circle to indicate we want to include 2, and nothing at the right-hand side to show that we don't want to include 5. So when we're taking the union, what we want to combine these two intervals together into one kind of super interval, if you will. So what I'm going to do is I'm going to take that first interval and kind of collapse it down onto the second, and now I can see what my final answer is going to be. I want everything from 1, including 1, up to 5, not including 5. So that would be my final answer if I had ended up with this from my calculations using the using the interval notation. All right, now how about this other one over here on the right? Well, I'm going to use kind of the same strategy. I'm going to start by kind of sketching -1 to 1, and I'm going to sketch 2 to 5. And when I try to collapse these down together, there is no overlap. They're still just two separate non-intersecting intervals. So in a situation like this, there isn't anything I can do to simplify this any further, and my answer is just going to be the first interval union the second interval. All right, so how about if we're doing intersections? Well, I've got the same two sets here, right? The only thing I've done is I've changed the unions to intersection, and I've also kept the graphs, right? Because visually we're going to be looking at the same diagrams. So remember, when we're talking about union, we want everything that the two sets have in common. We want their overlap. So if you look at the first set here, that is where they overlap. Right? So they overlap. The overlap is the numbers from 2 up to 4. And here's where we really have to think carefully. 2 is in both of the original intervals. So that is going to be included in my answer. So I put the filled in circle there. 4 is only included in one of the intervals. And to be in the intersection, it has to be in both of them. So I did not include 4 in my final result. All right, so if I wrote this with the interval notation, my final answer would look like this. All right, so how about over here on the other side? This is the non-overlapping case. And there's nothing I can draw. I can't draw those two vertical lines like I did with my first example because there is no overlap, right? And when we're talking about intersection of two sets that don't have any overlap, the way we write that is using the empty set. So that's how I would simplify really any situation where we're talking about the intersection of two non-overlapping sets. So I hope you found this helpful. If you did, please don't forget to click on the like button down below. And there are some links here to some of the other algebra related videos that we've got available.